Alright. Okay, so fundamental theorem of calculus. There's two branches of calculus, and so that's why they call it calculus AB, because the A part of calculus is taking derivatives and doing tangent lines. And then the B part of calculus, which we're already in, is integrating and doing area under a curve. Okay. So for differentiation, the difference between average rate of change and instantaneous rate of change was delta x, delta y, and finding average rate of change. And then we went and we moved from that to instantaneous rate of change, where we have dy dx, right? Okay, so then for integration, what we're moving from is we're moving from like average area over an interval to exact area under an interval, okay? Does everybody get it? Okay, all right, so there's two fundamental theorems of calculus. The first one is if you integrate a rate, you're going to get total change in the original function over the interval a to b. So what you do is you take the antiderivative of f of x and you get capital F of x, and then you plug in b, and then you plug in a, and f of b minus f of a will give you your total change over the interval a to b. Why does the plus c go away? Yes, it cancels it out, because really this is f of b plus c, whatever your c is, minus f of a plus c. And when you subtract f of b plus c minus the f of a plus c, the c's cancel. So on definite integrals, you don't need to write the plus c because you don't need to worry about the constant. The constant's going to cancel out. All right, so we call the definite integral total change, or when we talk about it in terms of position, velocity, acceleration, it's the displacement of your particle or whatever object. Okay, so that's fundamental theorem of calculus part 1. Once you've taken the antiderivative f of x into capital F of x, we usually do this line right here next to it saying make sure to plug in your bounds, b and a. So you'll see me using this notation where you take the antiderivative, don't need to worry about the plus c, then you plug in b, then you subtract a plugged in. Okay, let's do a couple of, well, first let's do real world, like what does the integral mean? Okay, so we have this original function f of t, and f of t represents the rate at which your 401k changes in value over the month of January. Okay, so f of t is the rate of our 401k. So our units of f of t is going to be our dollars per day, let's say, because it's a rate. Oh, sorry. So our rate is dollars per day for f of t. Now what is t in terms of? Yes, days. So this is days. And if we multiply f of t times dt, we end up getting dollars, right? Okay, so the integral from 1 to 31 of f of t dt, dollars per day times day, represents the total change in dollars of your 401k. Does everybody know what a 401k is? They don't let teachers have 401ks.
Like a different one?
Yeah, it's a 403b. we'll say in the month of January, but instead of in the month of January, you can say from Jan 1 to Jan 31, you know, because that's your need to write the bounds of your integral. That's this. There's two important parts. This part, the amount of money in your 401k, total change in the amount of money in your 401k, and then the bounds of your integral. Okay. Second one, R of t represents at the rate at which our pizza changes temperature in an oven 5 minutes after the pizza had been placed in the oven to cook. Had been placed. Ignore the was. Okay, so what happens when I take R of t and I multiply it times dt? I get what's my units? R of t times the minutes. I'll just get degrees Fahrenheit, right? So the integral from 5 to 20 represents the total change, make sure you say that, in the temperature and then you have to say units, degrees Fahrenheit. And then you have to say over what interval of time. So from 5 to 20 minutes. Okay, so you always have to write the units, total change, units, and the bounds of your integral. Okay, let's do one more. This one's the funniest one, guys. You and your friends are planning to buy a ticket to your favorite music group, the Newtons. Everyone wants to hear their latest hit, Why Integrate? Thanks. Okay, A of t represents the rate at which students are arriving. P of t represents the rate at which they buy their tickets. So if I integrate the rate at which students are arriving times the time, what do I get? Number of students arriving on the interval 1 to 5, right? What's our units for time? Did it say?
I guess minutes.
We'll say minutes. Okay. Integral of P of t represents the number of students yeah. A ticket on the interval 1 to 5 minutes. Okay, if I subtract A of t minus P of t, I'm gonna get what? So remember, A of t is a rate and P of t is a rate, so I'm subtracting a rate from a rate. So this will still be the rate. Okay, and what happens when I take away the people buying their tickets from the people arriving?
The number who haven't bought a ticket.
Okay, the rate at which the line is increasing or decreasing, right? Growing or shrinking. So if it's positive, then the line is growing, and if it's negative, then the line is shrinking. And then integral 1 to 5 of A of t minus P of t dt represents the total change in number of students in line on the interval 1 to 5. Okay. Cool. Got it? All right. Velocity is the rate at which blank is changing. I heard both. I heard position and acceleration.
Position.
Yeah, position. The rate at which position is changing. If I integrate from 5 to 50 of velocity, it will represent the total change in position on the interval 5 to 50. So if I have the total change in position on the interval 5 to 50, that's called displacement. And then A of t is the rate at which what is changing? Velocity. Okay, so if you ever want to get from acceleration to velocity, you integrate, and if you want to get from velocity to acceleration, you take the derivative. Easy peasy. Okay, I'm going to do one with you, but then I think you can do the rest on your own. The first one is integral 1 to 3 of x cubed. These are definite integrals, so we don't need plus c's. So integrate x cubed, and we get x to the 4th over 4, or 1/4 x to the 4. Then you do this little line dealio that says, make sure you plug in 1 and 3, and then you get 3 to the 4th over 4 minus 1 to the 4th over 4, right? And what is 3 to the 4th? 81 minus 1.
24 is 20.
80 over 4. 20. Okay, got it? All right. You try the next, the next 1 to 5. Okay. Let me know if you need assistance. Do the next 5, guys. No. But you should know how to.
Yeah, of course.
On multiple choice, it's going to be the simplified number, not the.
Where did I go wrong?
Does anybody need my help?
Minus 2, minus 2.
We learned the inverse of the chain rule.
No, minus 2. Oh, minus
What?
2.
Yeah, we'll learn it in 2 lessons.
Oh my god.
And then we are also going to learn the inverse of product rule too.
Can we extrapolate?
Huh?
Can we extrapolate them?
Yeah.
Yeah. Because I did it and then I was like, it's not that bad. This one, before you learn the reverse chain rule, just distribute it. Okay. How do you feel about this one? I might need to rewrite this. Forget a dx. Did you get that one? Hey. Oh yeah. Are they comfortable?
Miss Boyd,
Yeah.
for G,
G?
should we like do that one integral rule where a definite integral?
Oh, where you move this out?
Yeah.
Yeah, I would. I would leave that out and then integrate
It's a lot.
just that part, you know.
Okay. Yeah. Okay. I'll redo that.
That is okay. I think that's, is that what you got, guys?
Yes.
Okay, thanks.
Yeah.
I just put it back in. 16. Root 16, 4. 4 times 2 is 8. 8. And then this one we've got to distribute the denominator. Did you get it? Maya.
Come on.
only have me for 25 more minutes. Seconds? Gosh. Maybe. That's probably true. I gotta get to fundamental theorem of calculus part 2 quick. 2 cubed is 8. Okay, that's it. That's all of them. I'll give you a minute to look over them.
Do I have to simplify this?
No. Schedule is to this period till 9 o'clock, then third period from 9:05 to 9:40, then sixth period from, wait, hold on, this is wrong.
That's not for pep rally, I'm guessing.
Oh, this is the alternative one. This is the outside one. Okay, then sixth period from 9:35 to 10:20, and then fourth period from 10:25 to 12:05. Okay, everybody okay with fundamental theorem part 1? Steven.
Are we going to check if you have the pep rally?
What?
Are we going to check if you have the pep rally?
Yes,
Really?
What check?
you should go. Just go. I'm gonna tell you yes. But who knows?
Can I ask you a question?
Yeah.
If robotics is going to be during the homecoming parade, we need time to prepare. Are we able to, during the pep rally, prepare the robotics room?
I don't know. You'll have to ask your robotics people.
I'm wondering from the perspective of the pep rally, not from the perspective of robotics room.
I have no idea. All I know is I need my rally pepped, so you should get your rally pepped too. Okay, fundamental theorem of calculus part 2 is the easiest to skip that part, just go to here. But it's the hardest thing for people to remember. Okay, so if I actually integrate that, what is the actual integral of that? What's the integral of this? No, not u sub yet. So t to the 1/4, t to the 4th, right? And then we just have 0 and x to the 4th as our bounds. The reason why they use 2 different variables is because they don't want you to get mixed up. And so if you haven't plugged in x yet, then you know that you haven't plugged in x yet. Anyways, then I'll plug in my top bound and my bottom bound, so I get 1/4 t to the 16th minus 1/4 times 0 to the 4th, right? And then it simplifies to just 1/4 t to the 16th, yes? Oh, yeah, thank you. I need to fix it, because that's important. White out. Adine, white out.
It's on my
Is that part of your job description?
This is great.
Handing over-
Great TA. He's like the, in a operating room. Scalpel. But instead of scalpel, white out. Okay. If I take the derivative of 1/4 x to the 16th, what is the derivative of that? 4x to the 15th, right? Okay. Everybody's okay with this, yes? Yeah?
4x to the 15th?
4x to the 15th, yeah. For the derivative.
Oh, for the derivative, yeah.
Of 1/4 x to the 16th. Okay, yeah.
So it's just like the same thing, right? Except
Right, exactly. It's the same thing, only you have to do one little extra step. So, this is what happens. There's multiple ways that they'll ask you. They'll either ask you, they'll give you this and they'll ask you, what is f prime of x? Or they'll say, what's dy dx or d dx of the integral from 0 x to the 4th of t cubed dt. Those are the two ways that you'll see the fundamental theorem of calculus part 2 represented. Okay? Either way, you're doing the same thing. So this is the shortcut. Fundamental theorem of calculus part 2 says that the derivative of the integral, they cancel each other out because they're inverse operations of each other, right? And then you just take in the top bound and plug it in, and take in the bottom bound and plug it in. So we take x to the 4th, plug it into the cube because the derivative and the integral cancel out. Leave a little space here because I got to show you something. And then minus 0 cubed. And that's the second thing. Okay. But if I just do this, this doesn't get me to this. Why not? This is only x to the 12th. What am I missing to get to here?
Stretchy cube.
Because this is 0. So this is x to the 12th. What do I need to multiply this by to get to this? 4x to the third. Right. You know where that comes from?
Oh, it's the derivative of the x before.
It's the derivative of the x to the 4th. Yes, it's chain rule. It's exactly chain rule. Because, because this and this cancel each other out, right? So this and this cancel each other out, and so the derivative and the integral cancels out this level, right? But once you've plugged in x to the 4th, you've created a chain rule. So in order to take the derivative, yeah, this part you don't have to do anything. You can just plug it in. But just don't forget to multiply by what you plugged in. Okay. All right. So fundamental theorem of calculus part 2 says if you have a function and you want to take the derivative of it, it just equals f with the g of x plugged in times g prime of x. Nice job. Okay. And the 0, technically 0 is plugged in too. You don't have to write this, but technically the 0 is plugged in too. But you go minus f of 0, and then what's the derivative of 0? Yeah, so you're multiplying by the derivative of the inside, which is 0, and anything times 0 cancels out, right? So that's why we usually don't write that part when we're doing fundamental theorem of calculus. Okay? Yeah?
If it was just t to the, just t, not t to the third, would you still need to multiply it by g prime?
Yep. Yeah. If you plug something in, you got to multiply by the derivative. If you plug something in, you got to multiply by the derivative of what you plug in. Yeah. Okay, let's do problem 1. Okay, so if I'm taking the derivative of f of x, then the integral goes away, and so f prime of x will equal sine cubed of what? X squared, right? Yes. And then by chain rule, because the derivative of the integral cancels out this line, but I still have to take the derivative since I've created a chain rule, times 2x. And then remember, the 1 is still plugged in. It's minus sine cubed of 1. But what's the derivative of 1? Times 0. So this whole part goes away. So really it's just that. So you don't have to write it if you have a constant in the bottom. Okay, number 2, you can approach 2 ways. The first way is to flip it and make it negative. So just make this negative integral 5 to x of 1 over t squared dt. And then we can take the derivative. The derivative of the integral cancels out, but the negative still stays. And then x gets plugged in, 1 over x squared. Then times the derivative of x. What's the derivative of x? 1. So we're still multiplying by 1. You just usually don't see it if it's an x. And then the 5 gets plugged in, and it becomes plus 1 over 5 squared. But what's the derivative of 5? 0. So it's times 0. So this whole thing goes away. So it's just negative 1 over x squared. The other way you could do it is you could plug 5 in, and then that's going to be 0, and then you subtract the x plugged in. But I like flipping it first. Okay. All right. This one is the one that has both ends. So you've got to plug in both. So this equals the derivative of the integral cancel out. This just equals square root 1 plus x to the what? X squared in becomes x to the 8th, yep. And then I have to multiply by 2x. And then the bottom's not a constant, so I got to plug that in. So minus square root 1 plus x to the 4th, and then times 1, because the derivative of x is 1. And that's how you get that. Okay? All right. I got one more thing I need us to do. I didn't include this problem on your in your notes, but I wanted to do it. Do you have a calculator? Take it out. Did it go in your sandwich? Toss it back.
Did it land in your sandwich?
It better not be a quiz.
Huh? It's not.
It's
It's just an extra problem I want to do.
You could accidentally grade it.
Does Steven get one or no?
No, he doesn't.
He's too cool to school.
Okay, this one you can't integrate. Example 5 right here. You can't integrate this one, but you'll see this very often in a, tape this into your book. You'll see this very often on the AP exam. They'll give you something you can't integrate, but they'll tell you f of 1 is 3 and f of 2, and you have to find f of 2. And what you try to do is you try to integrate it, and then you solve for c using your 1 point, and then you plug in 2 to get your other point, but you can't actually integrate it. So for these problems, you can use fundamental theorem of calculus to help you, because you know that if I integrate e to the negative x squared dx, and you use these two bounds, 1 and 2, 1 and 2, by fundamental theorem of calculus, this is going to equal the integral capital F of 2 minus capital F of 1. Are you with me there? Yeah? Yes? Yeah. Okay. If you have a definite integral, the good thing is you can use your calculator to find the definite integral. So go Math 9 and integrate it. So we're using the fundamental theorem of calculus. Math 9 integral 1 to 2 of e to the negative x squared dx. Okay, that's 0.135. So this is 0.135 equals, and then you know that f of 1 is 3, so you just do f of 2 minus 3, right? Because f of 1 is 3. And then what does f of 2 have to be? Yeah, 3.135. Okay, cool. Does that make sense?
Bless you.
All right. There's 2 more problems that are good problems that will help you for your quiz. We only have 5 minutes-ish left, so if you want to start on those 2 problems, that's great. But if you want to save them and do them for homework, you can do that as well. So you've learned fundamental theorem part 1 and part 2.